To do this problem, I'm going to use the formula that your book has, where in the definition of doubling time, it's given as the initial size of the population, if it is n0, and the doubling time is a, then the size of the population at time t is given by this formula. N of t is equal to n0 2 to the power of t over a. So in this particular problem, for the first section, they've given that n0 is 500. So it's telling me that suppose a population doubles every 20 years. So this is my t value, if t is 20. And initially there were 500 members. So this is my n0. It's the question number A is asking, find a model for the community's population after t years. So to answer that, I'm going to use this formula, n of t equals n0 2 to the power of t over a, which means n of t is equal to 500 2 to the power of t over 20. And yes, that's what A is asking for. So this would be the answer for A. Okay. Now for B, the question is asking how many community members are there after 30 years. So when, in other words, if I have to say when t is 30, what is n of t? So I need to find the value of n of 30. So 500 2 to the power of 30 divided by 20. And if I want to simplify further, before putting it in my calculator, I can write it as 3 over 2, right? I can keep on going and simplifying it if I want to, but since I need a number, I will use my calculator. So I can just plug it in as I see. 500 2 to the power of, I can put a fraction there if I want, 3 divided by 2. Again, depending on your calculator, you may need to put a parentheses across the 3 over 2 or write it as, as a decimal. Okay, so this is what the answer is asking. How many community members? So I need to round it to the whole number. So the correct answer would be 1414. Yeah. 1,414 community members are there after 30 years. Okay. Now the next section, C, is something you need to use some properties of exponents, and a little bit more logarithmic skills are required to solve this problem. So first let me set it up. So where it's saying when will the population, so when will, it's technically asking me what the t would be, right? T is the population be for the community to reach n of like 10,000. So this is given to me as n of t. So what's telling me here is, if I set it up, if n of t is 10,000, again starting with the equation for 8, n of t is 10,000. I already know that I have 500 in there, 500 2 to the power of t over 20. So how do I solve for this t? Okay, now I hope you all know by this time that this is an exponential equation. Why? Because the variable is in the exponent, and the only way I can solve an exponential equation is either if I can apply the properties of log, or I have to apply the rules of exponents. So rules of exponents is, if I can make my bases the same, like here this 2t over 20 is my this is my exponential piece. So if there is any way I can make my bases the same by isolating the 500, then I can equate my exponents. That's one option. If not, the other option is taking log both sides. So let me write 10,000 divided by 500. So first I need to divide 500 both sides. Needs another color here. So divide 500 both sides. So that will eliminate this 500. So 10,000 divided by 500, right? So 2 zeros would go off. Again, 100 divided by 5. If not, you can use your calculator. Divided by 500. So I have a 20 is equal to 2 to the power of t over 20. The base is 20 on the right and 2 on the right and 20 on the left. So I cannot use the properties of logs. So therefore I need to follow these steps. Take log each side, then I have to use the properties of log and then solve for t. So when I say take log each side, I can either take log or even ln. So here I'm going to use ln. Okay, so from this step here, I'm going to say take ln both sides. Okay, so my left would be ln 20 is equal to ln 2 to the power of t over 20. Now to the right hand side, I'm using the power rule. And I am going to bring this t over 20 and multiply it before the log. So that is going to give me ln 20 is equal to t over 20 ln 2. So ln 2 is a number, so I'm going to divide and then multiply. So this isolate t by itself, so t would be equal to ln 2 would come to the denominator and 20 would go to the numerator. So 20 ln 20 divided by ln 2. Again, you cannot cancel the ln's. The only way I can do this is by using my calculator here. So I'm going to put 20 ln 20 close parentheses divided by ln 2. Now if I want, I could have put a parentheses across the 20 ln 2 too, but it doesn't matter because it's multiplication and division. So here if it's dividing and then multiplying by 20, it's fine, or if it's just multiplying and then dividing by ln 2, it's fine too. So I would have the answer as 86.4385, and I will round it off to, so t is approximately equal to, from the calculator, 86.4385, or I can say t is approximately 86.4 years. Make sure to put the unit, and that will be the answer to C. So just to recap, the answer to A is, this is my answer to A, this is my answer to B, and my answer to C is 86.4 years. This is one of the problem that needs a little bit more attention, so if you don't understand, please send me an email or